welcome my dear students to my channel Mathematics Made Easy. This is Miss Ruchika welcoming you to today's session. This is a last minute revision video which has been put by me especially for my grade 10 elite students. Some of you were requesting me for part 8 where we are talking about chapter 7 linear programming problems. So one of my subscriber Mahara had requested for this video. Also, few of my other subscribers are also wanting to see some word problems on linear programming. So here I am with this video, and it has been taking my weekend to make these videos. So humble reminder, just to help you, I'm making this video, taking out time from my busy schedule. So please do share this video with your friends, give it a thumbs up if you find it useful, and don't forget to subscribe and hit the bell icon so that you don't miss any upcoming videos. More doubt covering videos are coming up over the weekend just before your math exam so that I can help you for the same. So let's start with today's video and see what problems are we covering today. So basically the request I got was from page 10 to page 11. These are some word problems 23 to 28 that we'll be covering in the session today. I will be showing you how to solve some of them, and very similarly you are going to solve the remaining problems. So let's start with the first linear programming word problem and see how it is to be solved. Okay, so now we are going to write the inequality. So x greater than equal to 0, that's the first inequality. Next, second one, y greater than equal to 0, that's the second inequality. Next one, 2 times x plus 3 times y is going to be less than equal to 450 hours. So that's our next inequality. So now that we have 3 of them, let's look at the common region, the feasible region. So we are going to zoom out and we are going to see here that this triangular region with the 3 corner points, one is origin 0, 0, one is 0, 150, one is 225, 0, right? So I'm going to also be taking a screenshot of this and showing you. So the common shaded region is this right angle triangle. Now at these 3 corner points, we are going to calculate our objective function, our revenue function. So let's go back to our presentation and then make a table of values. And if you see here, 0, 0 can be neglected because it's the minimum point. We need maximum. So we can also substitute just for these two and get our answer. So let's go to our presentation back again. So many of my students which are already studying from me, they know that when we are solving a word problem, the first thing we do is to read it at least 2 times. And the second thing we do while we read it for the second time is to highlight important information. So let's read the word problem loud and clear and try to understand what it is asking and what we need to find. So there's this girl Zainab who has a bakery shop and she's selling 2 types of cake. Number 1 is a yellow cake which sells for $25. So you can take it as dirham here, and then she's selling a strawberry cake which sells for 35 dirhams. So both cakes are of the same size, but the decorating and assembly time required for the 2 cakes is different. So the yellow cake takes 2 hours while the time for the strawberry cake is 3 hours. So we are underlining important information while we are reading it, and we know that there are a total of 450 hours of labor that's available for the production of these 2 cakes. Now the question is asking you how many each type of cake should be made to maximize the revenue. So this is a maximization problem. We need to maximize the revenue. Let's denote it with a capital R. So step 1 in this kind of a problem is to write the linear programming problem. Now we need to find how many of each type of cake, and there are 2 types of cake. So let's take x and y, 2 variables to denote the number of cakes. So x is the number of yellow cakes made, whereas y would denote the number of strawberry cake made. So like a yellow cake could be a mango cake which is quite in season, and a pink cake would be a strawberry cake, which I know most of you must be liking. Any which way, so we have to choose the variable here. So I've chosen x and y to denote this number. So generally a hint would be, a trick would be, what you need to find, you take it as the unknown. So here you need to find two types of cake, so you choose two variables x and y. Okay, so we need to find this x and y, and what information in the word problem is given for this x and y. Let's see. We know the cost of one uh, yellow cake, sorry, one yellow cake, the cost is how much? $25. And for one strawberry cake, it is $35. So if for one yellow cake the cost is 25, then for X yellow cakes cost would be 25 times X. So it is just like, if you buy a slice of a cake, it is 25, and if you are 5 friends going to buy, then it will be 25 multiplied with 5 amount that you pay, which will be 125 dirhams. Similarly, for one yellow strawberry cake, the cost of one cake is 35 dirham. So for y number of cakes that are produced, this will be the total cost. So that's what is the total revenue variable. I hope you understand how we are writing it. So revenue, in other words, if any one of you don't know, is the cost. So it is the cost of making these two types of cake. So the cost here denoted by variable r is to be maximized. So we want to maximize this profit that is being made. So 25 times x plus 35 y. Okay, so we have this variable. Now such that now we need to define the condition, the constraint. So the first condition would be that your x would be more than 0. So there are some number of cakes, 5, 10, 15, positive number of cakes that we are producing. So both are 0. Greater than equal to 0. What is the next thing? The time. So how much time the first cake is taking? 2 hours. How much time the second cake is taking? 3 hours. So the next equation that will come would come from these x and y. So can I say that for one cake, yellow cake, 2 hours. So for x cake, how many hours? 2x. Similarly, for one strawberry cake, the time is y. So for one cake the time is 3 hours. So for y number of cakes the time would be 3y. So this is the total time that is spent on making, on assembling and decorating these two cakes. Now another condition which is given is that there are 450 hours of labor. That means this is the maximum number of hours that the baker can spend on baking the cake. So this cannot be it cannot be 451 or it cannot be 500 hours. It has to be less than or equal to 450. So this is like a maximum number of hours that can be spent. So here you get 1, 2 and 3 condition. Is there any other information given here? No. So that's our linear programming problem. LPP is the short form for denoting linear programming problem. And what is this problem? This is a problem of either maximization or minimization. Here it is maximum, so we are going to use these conditions to draw the graph, to graphically represent the solution, and then we are going to find this answer. So first you need to understand this. Now we are going to go to a software called Desmos Graphing Calculator. I'm just going to show you that and also provide the link in the description box. Please, you can visit the link and draw your own graph. Some of you might be knowing. So we are going to draw the graph of this inequality, and this inequality, and then we will select from there our feasible region. So feasible region is like the shaded common part. That would be the next step of the solution, and from that shaded common part we are going to look at the corner points. Okay, and at those corner points, like the coordinates x comma y, we are going to calculate our objective function, our revenue function, and wherever it is going to take the maximum value, that would give us our answer, our values of x and y. So let's go to Desmos and complete our solution. Okay, so let's now calculate the objective function at the different values of x and y. So our revenue function R is defined as 25x plus 35y. Now we need to calculate this value at different values of the point. So the first point was 0, 0. So at this point, the revenue function would be 25 times 0 plus 35 times 0, which is 0. So not useful. We need the maximum value. So let's complete the table. Next point was 0, 150. At this point also, x is 0, only y value is given 150. So this will come out to be 35 multiplied with 150, which is 5250. Last point is 225, 0. So x is 25 multiplied with 225 plus 35 with 0. So let's calculate this value also. 25 multiplied with 225. So this is coming out to be the maximum value 5625. That means this is our correct answer. So we now change our solution. So x equal to 225 and y equal to 0 is our solution. And what is the maximum revenue? It is $2625, which is being produced. So the number of yellow cakes is 225. The number of strawberry cakes is 0, which is giving the maximum revenue. That completes your question. Let's see another problem just to make you more comfortable with linear programming problem. So again, it's a word problem. Let's read it together and highlight the important information. The manager of a travel agency is printing brochures and flyers to advertise special discount on vacation spots during the summer months. So what kind of two things are printed? Number one is brochure, number two is flyer. Now each brochure is costing $0.08 to print and each flyer is costing this much dollars to print. So highlight the important numbers here, and then a brochure requires how many pages? 3, and a flyer requires 2 pages. So we are underlining, highlighting all these numbers given. The manager does not want to use more than 600 pages. So there's a restriction on the maximum number of pages here. 600 is maximum. Less than that is allowed, but not more than that. And he needs at least means minimum 50 brochures and 150 flyers. So this is also another condition that we will use to write the constraints. How many of each should he print to minimize the cost? So this is a minimization linear programming problem. Minimize cost. So I'm denoting with capital. And this cost is how much for, or maybe you just draw a flow chart. So one is brochure, one is flyer. For brochure, cost to print is 0.08. For this, it is 0.04. So the cost will be 0.08x plus 0.04y. Now I'm taking the number of brochures to be x, number of flyers to be y. Okay, so again, two variables x and y. So this is the objective function such that now let's see what is the condition. How many brochures? At least 50 means minimum. So brochure is x. So minimum means more than equal to 50 and flyers more than equal to 150. So first condition, second condition. We've used this information. Let's go now to the number of pages. How many number of pages? 3 pages for one brochure. So 3x. How many pages for one flyer? 2, so 2y. And this should use does not want to use more than 600. So that means less than equal to 600. That's condition 3. Okay, so have we used all important information? Let's see. We use these numbers, we used the number of pages, and we used this also. Okay, so our linear programming problem is complete. This is the LPP. Now we need to find the feasible solution. We need to find the shaded region. Now, if you don't want to use Desmos, you want to draw it yourself, you can also do. What you are going to do in that case, you will convert these inequality to equation. So you can also graph yourself without using calculator x equal to 50, y equal to 150, and 3x plus 2y equal to 600. Then you look at greater than equal to for these two conditions and less than for this. Okay, and just to save time right now I'm going to do this on Desmos, because if I do it from without using Desmos graphing calculator, answer will be pretty long. So I'm going to use this only, just like we did for the last question, and then we'll look at our shaded regions. Let's go to Desmos and see the graph. The first inequality is x greater than equal to 50. The second one is y greater than equal to 150. So I hope you can see how the graph is changing. Next is the last one, which is in terms of the number of pages. So 3x plus 2y, this has to be less than equal to 450. Okay, so we are done with all. Let's zoom out and check our answer. So this is how the shaded region is coming. Little bit more, I'll zoom. So what is the shaded region? It is this triangle again. So the triangle has 3 coordinates. As you can see, I'm going to take a screenshot. And for x greater than equal to 50, it's the above region. So this is 0.50. So more than that. For 150, this is the line. So y more than 150, it's that region. And for this line, it is this one less than. Okay, so if we go down, yes, so this area, the area which is the shaded region, is got from these 3 points. Let's highlight the points, and now we'll go to Desmos, and we'll go back to the presentation, and we'll check our answer there. Okay, let's solve this question. Now, if you see carefully, x has to be greater than equal to 50, means this is 50, so we are moving on the right side. Okay, this point is 50, this point is 150. Y has to be greater than equal to 150, means this area. And 3x plus 2y has to be less than equal to 140, means it is this area. So do you see here that there is no region which is common and bounded? So the only point that you see here which is common to these area, this is a case of unbounded feasible region, is this point, which is 50, 150. So the only solution possible in this case is just one point, 50, 150. I hope you're able to see why we are ignoring these 2 points, because these 2 points don't satisfy this feasible region. Your x has to be more than 50, this part. Your y has to be more than 150. This is satisfied only with this region and this point, not these 2 points. So the only solution is this. Therefore, the number of brochures, or the number of pages, let's just correct this, the number of pages. So the number of pages in brochure would be 50, and the number of pages in flyers would be 150. That would minimize the cost, and if you want to calculate the cost, it will come out to be can go to the objective function 0.08 multiplied by 50 plus 0.04 multiplied by 150. Calculation, this will come out to be, let's just do it in the calculator, 10. So $10 would be spent. That's the minimum cost to this linear programming problem. So that's how you do the questions. Now follow the same process for this question, and I have provided you the answer key here. Please check your answers. In a similar way, we can solve these questions 26, 27 and 28. Let me show you the answer key for 26 and 27. Now we'll try and solve a few problems. So let's do in detail uh, question number 27. Yes, and for question 28 the answer key is also provided. Same method you are going to use for the linear programming problem. So the first part of question 27, let's try to solve. So here we are going to do the same process. We are going to highlight the important information. So let's read the word problem. Each car on a freight train can hold 4,200 pounds of cargo. So that's the total amount of weight that this train can hold, and the capacity of 480 cubic feet. That's the volume. So the freight service handles two types of packages: small, which weighs 25 pounds and are 3 cubic feet each, and large, which are 50 pounds and are 5 cubic feet each. Okay, so again we can denote x and y variables. X variable will denote for the small package. If you see, find the number of each type of package that should be placed to maximize revenue. So x is the number of small packages that we are going to take, and y would be the number of large packages that we would take. Okay, and for each of them you are given specifically 25 pounds. That's the weight, 25 pounds, and the volume is 3 cubic feet. Similarly, for big one, it is double, so 50 pounds and 5 cubic feet. So you have to look at the important information. The freight service charges $5 for each small package and $8 for each large package. You have to maximize this revenue. So can I say the revenue would be maximum R equal to, for one small box it is charging 5, so for x small packages it will charge 5x plus similarly 8y. So that's the maximum revenue. Now we need to determine the condition. So first you need to find what is the maximum revenue, and then you have to answer this situation. The answer key would be this, but let's go and see what are the steps. So if you go to the steps, x is definitely going to be greater than equal to 0. Here you need to select all the inequalities that represents the condition or the constraint. So we have taken x to be the number of small package, y to be the number of large package. Again, y and x both have to be positive. That's one condition. Now, if we talk in terms of their volume, so we can also have this condition 3x plus 5y less than equal to 480, and then in terms of the cubic pounds, 25 pounds was for small package. So for 1, if it is 25, for x it will be 25x plus 50y. Now you can go to Desmos graphing calculator. We are just going to do that. Otherwise, without a calculator also you can do x greater than equal to 0, y greater than equal to 0, second condition, and then 3x plus 5y less than equal to 480, and then 25x plus 50y less than equal to 4200. Let's do all of these conditions there and then check our answer. Okay, so the first condition is x greater than equal to 0. Next condition is, let's go to the second one, y greater than equal to 0. The third condition is 3x plus 5y is less than equal to 480. And last but not the least, 25x plus 50y is less than equal to 4200. Okay, now we need to zoom out to see the common shaded region. Okay, so x greater than equal to 0, y greater than equal to 0 is very easy. It will be the region on the right and region on the first quadrant. Okay, now for 3x plus 5y, that's the green part, this line has to be less, means inside. And then for the next one, 25x plus 50y less than equal to this, the purple one, we need less, so means this. So the point is 1, 2, 3, and 4. 4 points. So we have got all 4 points. Let's go to now back to our presentation and calculate our objective function at these points. So we'll stop the recording here. Okay, so now we need to select the correct graph. So as you see from your own graph, the correct answer is going to be A. And here the points that we are considering are 0, 84, 120, 24 and 160, 0. So at these 3 points, we are now going to draw and check for our objective function. We need to maximize our revenue. So let's go back to the question and finish it up. So our maximum revenue function had come out to be 5x plus 8y. Now we need to draw the table of values for these x and y. We need to find this revenue function and we need to see at what value is it becoming maximum. So let's do this calculation. The first point is 0, 84. The next point is 120, 24. And the last point is 160, 0. So the calculation would be 5 times 0, where there is x, you put 0, where there is y, you put 84. So we are just doing substitution. Where there is x, put 120, where there is y, put 24. Similarly, here also 5 times 160 plus 8 times 0, calculate the function. So here your f of x y will come out to be these values. Complete the question. You can just do the calculation and the answer that would come out would be this one. Okay, so the maximum value as you calculate would come out to be for this value. So the maximum revenue is going to be generated from this. So the solution will be the company should load 160 small and 0 large packages on each truck to maximize the limit, because X was representing small and Y was representing big value. So that completes the question. So I hope with that I have answered your doubts for Mahara, and also this was a session on linear programming problem that all of you find useful. Many of you had doubts in these word problems, so I have now made them simple for you. Make sure you watch the video till the end as it takes a lot of effort, and give it a thumbs up if you found it useful. Share it with your friends who are going to give the exam, and don't forget to press subscribe button and also to press the bell icon not to miss any upcoming videos. So more videos are lined up clearing all the doubts of grade 9 and 10 students. The next video also is going to be coming shortly in the morning. So stay glued to the channel and all the very best for your coming exams. Bye bye.